Sure. Okay, no worries. Okay, good morning to everyone. Let me start with my session with this title. So this is what I'm going to do. I'm going to take you through certain set of slides that explain the sentiment analysis, and we'll be using NLP for that. It is not exactly related to SQL Server, but it is heavily related to data, and we are using this type of implementation with Microsoft Azure platform, Microsoft SQL Server. But I thought was like having a session like this will be really helpful for you to integrate all type of data services in your data environment. So let me introduce myself. My name is Dinesh Priyankara, and uh, I have this MVP title since 2006, and I'm certified trainer. And you can see some of the links that I use for contributing to the community. And I've been working with the SQL Server data related services for last 18 years, and I have implemented many data warehouses, reporting solution, integrated solution, data science, big data solution, and the standard SQL Server solutions. Right. I'm not going to spend much time on this. I know that when we do this type of virtual event, it's very difficult to see whether the audience has question, but I'm sure that organizers will support me on that. So thank you very much, Asif, Pure, and the organizing team. One is having me, and then organizing this virtual event. Of course, we were expecting to have a physical event, but unfortunately, because of the situation in the world, we had to go for virtual. Okay, right. So let's start. So we're going to talk about sentiment analysis. This is what I have planned. So I'll be taking you through certain set of slides that explain sentiment analysis and what is it, what sort of things we really look for. And then we'll see if you're really implementing this type of things with our data set. What are the challenges we are going to experience? And at the end, I'll show you two demonstrations, not very lengthy one, two simple demonstration where you can which you can actually see what sort of code we have to write for implementing something like this. Microsoft has various built-in support for this. For example, if you go for cognitive services, you can find sentiment analysis services, APIs that can be easily used. But I'm not going to use those things because I want to show the way of coding. In this case, I'm going to use Python, and then you can understand the exact way of handling data sets. Right. So let's try to understand what is sentiment analysis. So this is all about getting the. I believe that everyone can see my slides, right? I'm moving slides. Asif, can you confirm that?
Yeah,
Okay,
you can
fine.
see.
Okay.
Yeah. Okay, please.
Right. Okay. So sentiment analysis is all about understanding the opinion or how others think about something. Uh, for example, if you ask whether let's say you're asking from a person whether this person likes the book you have written or not, or you ask whether the particular movie has been watched and whether you like that movie or not, something like that. So the respond for something like that, or the question like that, can be considered as sentiment analysis. It's all about the answer we get has a sentiment value or not. But it's very difficult to determine whether it is a positive answer or the negative answer, or it can be neutral as well. So we need to figure it out, how we can easily find the sentiment value of this type of answer. In a way, it is not easy unless you know the context. For example, if I ask you now whether you like this session or not, you might say, now since this is virtual, I have no way of seeing your face, so I have no way of determining whether you really meant it or not. You might say yes, I like it, but it's very difficult to determine whether you really meant it or not. So we have to write some codes for understanding or handling this situation and get the sentiment value out of the answer you have given. So that's called sentiment analysis. It's all about finding the exact meaning of it. I have added few points on this. So if you go through the slides, you can understand certain important things we have to know in terms of sentiment analysis. So we talk about positive, negative, and neutral. We always try to check and see whether the reply, the feedback, or the answer we got is positive or negative. And you can see some sample questions. Is the movie review positive or negative? The feedback received positive or negative? In addition to that, this operation or this analysis is called using multiple terms like opinion mining, sentiment mining, verdict analysis, subjective detection, and there are multiple types of you know terms we can use.
Hi Dinesh, we cannot hear your sound. I think
I'm
the
sorry, it has gone
yes,
for
yeah.
mute. Yeah, I'm sorry. Uh, I don't know how it happened. Sorry for that. I explained this slide. Everyone heard about it or not?
I think no. So maybe from the last slide.
I'll quickly go through. Yeah, I'll quickly go through. So, I'm sorry for that. Uh, so, let's say we hear something like, "I have to think about this dress." Somebody's, saying something like that. When you hear something like that, it's very difficult to determine whether it's positive or negative. But if we see the real picture, if we can really see the persons who really make this statement, we can easily understand it. For example, if this statement is coming from the first person, it looks like it is positive that she likes this dress. But if this statement coming from the next person, it looks like she doesn't like it. So if you see the context, you can easily determine whether it's positive or negative. But if you just see the text, not just the not just the the audio part, then it is bit difficult to understand it unless you see the context of it. Let me take you through another example quickly. So if you hear something like, "I have never ever had such a pizza before," and if you really see the person, then you can understand, you can easily determine that the statement is a positive statement. But if you do not see, if you are really going through the text, it's very difficult to check and see whether this is positive or negative. For example, it can be something like this as well. So this is where we get stuck with text mining, you might get a text which cannot be easily determined whether it is positive or negative. But if you really train the machine to understand these statements and analyze and then find the sentiment value of it, then of course you'll be able to get the value saying that it is positive or negative up to some extent. It is not going to be 100% accurate in every cases, every instances, but you'll be able to handle it. What is text mining? In that case, I can say, let me take all of these things. I have to cover everything within 45 minutes, so I'm not going through all my slides in detail. I'm trying my best to have some demonstrations. So what is text mining? So it's all about making sense out of data, and you can say data mining on text data as well. And text analytics is a synonym or another term we use, and we always consider NLP, natural language processing, for this. So there are multiple environments or the categories you see the usage of it. One is text mining for prediction, other one is text mining for pattern recognition. We can use NLP for predicting the sentiment value, or you can actually use NLP or the text mining for finding patterns based on various other factors. So if I have to summarize it, this is how you have to summarize this. Text mining is all about deriving meaningful information from the natural language. That's how you need to think. So I have added these slides about text mining because that is related to sentiment analysis. One thing you need to understand is whether text data is structured or unstructured. In a way, you can think it as structured. If you have large number of text that needs to be analyzed and you want to find the sentiment value of that text, you can put it to a table with one column and say it is structured. But generally, if you take a sentence or the value or the record or a cell in this record set or the table, it has to be considered unstructured because it contains a certain number of values. So likewise, we have certain areas to be considered when you do text mining or sentiment analysis. How many columns we can set with this text data, or do we have to really go for columns? What's the length of this statement or the document? Can we arrange it as a data set, or can we apply some mathematical formula for it? So likewise, there are a certain number of issues or the things we have to do in terms of handling data. Generally considered as unstructured, that's easy, because if you consider the text as structured, then you'll be trying to use standard data processing or data manipulation techniques for finding the sentiment. But if you really consider this as unstructured, then you know how to work with unstructured data, and you'll be using the right tool, right language, and right command for it. A few more things to be considered. We know that machine cannot easily understand what we have given. For example, I'm passing a text saying, I like this person. So in order to find whether it is positive or negative, I can ask the machine saying, just try to get the sentiment value out of it. But we know that machine cannot easily understand. Machine doesn't know whether it's a sentence. It doesn't know whether it's a word, or it doesn't know the context of it. So how do we train the machine in order to make sure that machine can understand all of these things? One way is, yes, we have the unstructured data set. You have to use the machine for converting it to structured data set, and then we can use the machine for getting the sentiment value of it. So one thing you need to remember is, even though we are working with unstructured data, you have to make sure that you convert it to some sort of structure, and then ask machine to learn it, understand it, find a pattern of it, and then you can use it for sentiment analysis. There's another thing you need to consider. The text you pass for finding the sentiment, or even before training the machine, it might contain a certain set of words which cannot be easily used for sentiment analysis. Things like this, is and are, or abbreviation like this, USA, America, or certain standards like this. And we know that we cannot just make sure that every sentence or the document you have the root word of the verb. So you might be seeing various ways of describing things. For example, if you think about the verb called come, you'll be seeing a different words related to come, like come in, came, different ways of using it. So how do you handle all of these things? So we have numbers, certain things in uppercase, some special characters. How do you handle all of these things? One thing you need to do is, when you pass your text to the machine.
Hi, Dinesh. I think we are not able to hear you again. I think.
Dinesh, I think you're on mute again.
Can you hear me now?
Yeah, there you go.
Yeah.
Okay. So I was explaining that the certain areas we have to consider. So you might get text like this with your data set to be analyzed. So you need to make sure you handle these data sets. And certain techniques we use for processing or making sure data set is ready. So we have something called tokenizing. So that's one of the steps we use. So tokenizing is all about in simple terms, I can say breaking the text into multiple or small units. For example, I might have a document and I can split into sentences. That's sort of tokenizing. Or I might have sentences I need to split into words. That's also tokenizing. So this is one technique we use for organizing our data set for sentiment analysis. Then we have two things called, let me load these two, stemming and lemmatizing. That is all about making sure we do not use all types of words. We use we use words or we use the root word. Hello.
We can listen to you.
I can hear you.
There's no sound.
Can you see I'm sorry, like so many interruptions. Can you see my screen and can you hear me?
Yeah, I can hear you now. Yeah.
Okay, so I was explaining the tokenizing part, and then in order to make sure that all words used with my text or the documents are using the root word, like for example, rather than using go in, go on, I need to make sure we use go. Things like that, we apply two techniques called stemming and lemmatizing. I have slides explaining these two, so I'll quickly take you through those two slides to understand the difference between stemming and lemmatizing. And we just noticed that some of the words have to be removed, like is and are. That's called stop word. So we have to remove those words. And if you have special characters, special letters, those have to be removed as well. So tokenizing, I explained this. So we talk about word token and sentence token. If you have to tokenize a document and you need to take everything as sentences, you'll be going through sentence tokenizing. Or if you have certain if you have sentences, then if you want to split into words, you can go for word tokenizing. Somehow you need to split this into a small units, then machine can easily understand your data. And the stop words, we talk about it. So stop word is all about finding these the words like is and are, so you can remove those things because we don't take those things to sentiment analysis. Then stemming and lemmatizing. So let me open all these. So stemming is all about finding the root word. It is, in a way, it is the simplest way of finding the root verb for given various words related to verbs. And there's a small problem with stemming. Sometimes stemming results words that are not actually exist in dictionaries. For example, if I go for the next one, this talks about lemmatizing, but this has an example for, see the first statement, you might end up with a word like become, which has only 5 letters like BECOM if you use stemming. The reason is stemming is not really complex. It tries its best to make sure it brings every word into a certain level. So in that case, you might end up with the words which are not exist in dictionary. So as you see, becomes a become, but not with all 6 characters or 6 letters. It ends up with 5 letters. But lemmatizing, if you use lemmatizing, it makes sure that the end result is a real word. So you're not going to see a word which is not exist, which you have never ever heard or seen. It will give you a word which you can understand. But again, this has a small issue as well. It might give a word which is not related to the original word. So you need to decide whether you're going to use stemming or lemmatizing, but simply you can test and see, because when it comes to text mining, sentiment analysis, when you do the training part, it is not something like you apply the technique and get the result. You have to continuously do tests. You apply one technique, see the result, and if it is not the one you expect, then you try with some other techniques. Okay, so this is something we use for transformation. So we talk about stop words, tokenizing, lemmatizing, and stemming, and you might have to apply some regular expressions as well, because we need to remove certain characters. For example, if you see numbers, if you see $sign, you don't need to pass those things for text analysis or sentiment analysis. So you have to use regular expressions for removing those, right? So as I told you, in order to make sure that machine can understand your text, which has to be considered unstructured, you need to convert them into a structured manner. So we use something called DTM, document term matrix. When you have a number of text, when you have a number of documents, we try to create a result, a structured result like this before we pass the data set to the machine for training. For example, if you have 3 documents, you can see the first document is love this place, good pizza, and second statement, at this place crust is not good, pizza is not good. Likewise, if you have multiple text like this, we have to apply all this transformation we just discussed: tokenizing, stemming, lemmatizing, remove stop words, and all. We have to end up with something like this .dtm. So you can see the table. So you can easily understand what has happened is, if you have 1,000 text like this, you'll be having 1,000 records. But the number of columns is completely based on the number of words or number of unique words you have in all your text. So if you might end up with 10,000 columns, 100,000 columns, it doesn't matter, like as long as your machine can handle it. But you need to make sure you convert your unstructured data set into a structured data set like this, which is called as DTM. Then only you should pass it to the machine and ask machine to learn it, and we have to pass the sentiment value or the the original sentiment value of this sentence along with that. Then machine can actually learn it, or machine can find a pattern of it, and then we can use it for prediction. Okay, right. So to summarize it, how do you do the sentiment analysis? You get your text, tokenize it, remove all the stop words, and handle all other pre-processing techniques like stemming, lemmatizing, and then use something like classification, because anyway this comes under classification, because you want to find whether the given statement is true or false, positive or negative, something like that. So which means you are trying to categorize your statement, so that goes as classification. So if you think about the overall process, this is how it has to be done. we have to think about few challenges we experience when we do something like this. So you might get certain words. So let me open all of these things. So see these two examples. So let's say we are trying to get opinions related to the book you have written. So one person say this book is fantastic. So other person, the feedback of the other person is color of the book is blue. Now, when you do when you pick feedback related to your survey or related to your book, you need to carefully pick it, because you should not take text like you can see the second one, color of the book is blue. Why? It is objective. How do you know whether it's objective or subjective? If you feel like it can be proven, given feedback, okay, given answer, given reply, if you feel like it can be proven, do not take into your sentiment analysis, because it is objective. We have to always make sure it is subjective. If you think about the statement given, this book is fantastic, you cannot prove it. It is said by someone. It's very difficult to prove it, and that's what you have to take for sentiment analysis. So always make sure you pick subjective text, not objective text. That's one of the challenges you experience when you do sentiment analysis. And the other thing is context and polarity. It's all about checking whether you understand the context of the feedback given. For example, if you know the question that have been asked for the survey, for example, in this case, the question is, what did you like about the book? One person can say everything of it, and another person can say absolutely nothing. Since you know the context, you know the first one is sort of positive and second one is negative. But when you go through all your data, for some reason, if the question has been changed, it means the context has been changed. Let's say the question has been changed, like, what did you dislike about the book? Then it's very difficult to determine the real sentiment value of it, because certain feedbacks based on the question type 1 and certain feedback related to the question type 2. So if you do not know the exact context, it's very difficult to continue with sentiment analysis. So again, this is a challenge. You need to make sure you understand the context and you stick into that context. And this is also another big issue when we do the sentiment analysis. We cannot easily understand whether it is really this person meant it or not. For example, as you see in the picture, if you just have this text, very impressive, can't you see my excitement? If you just have this text, you might take it as positive, but if you see the face of this person, then you know that it is not positive. So this is also a challenge, determining whether it is sarcasm or that person really meant it. Now, if you ask me whether we can handle these things automatically, it's very difficult. That's why I have added them as challenges. So sometimes we cannot handle all of these things through codes. You have to do certain pre-testing or certain transformation before you go into codes. And we have comparison as well. So if you have comparison to things, you need to consider about it whether you really compare with two real physical items, or you compare with one item with something not exist, something not related to the environment, not related to domain, or you don't have the context of it. So consider all of these things. You might get emojis as well. We know that there are two types of emojis, Western and Eastern. So if you take these emojis for your text analysis or sentiment analysis, just make sure you understand the characters of it. Because Western, we basically try to do things with 2 characters, and Eastern, we try to do things with 3 characters. Right. So another challenge. Now we know that we want to find whether it is positive or negative. But how do you find whether it's neutral or not? So it's basically up to you. You can decide now. If you try to get the sentiment value of the text in using mathematical formula, you might get a value. So you have to decide the threshold. Okay, from this point to this point, I'm consider it as positive. From this point to this point, it is neutral. Or value above this number or value below this number, it is negative. So you need to decide it again. It is something you have to decide. It's something you have to decide based on your experience. You might get support from some codes, but not always. Right. So how do you do all of these things? I believe that I have 10 more minutes. So it's time for doing the demo, but let me tell you how, what sort of ways of handling or implementing a software solution for sentiment analysis. We have basically two types of ways. One is rule-based system, other one is automatic system. For example, if I want to find out whether something is positive or negative, first thing I can do is I can collect all my positive words and put it to one container. Then I can take all my negative words and put it in another container. So I have certain two containers. One has positive values, one positive words, and my second container has negative words. Now, if I'm getting a sentence or the text to be analyzed, and if I want to find the sentiment value of it, I can just check the number of words. Like I can take number of words exist in that text and check and see whether how many words out of that, how many words are, or how many words related to my first container and how many words related exist in my second container. So based on the number, I can say that it is positive or negative. For example, if I have a word with, if I have a sentence with, or the text with the 10 words, okay, let me repeat that. If I have a sentence with 10 words, and if I see, 7 words out of 10 in my positive container, I can take it as positive. So that's called as rule-based system. You can write codes for doing it. You can use certain NLP techniques for doing it, or even for transformation. Automatic system is you use actually machine learning techniques for doing it. So that's where you use certain algorithms. You can go for hybrid system, but it is always better to stick into one and continue. So if you go for automatic system, this is what you're going to see. These are the techniques you can use: naive Bayes, linear regression, support vector machine. And if you really want to go into the depth using AI, you can go for deep learning. So we don't have time for discussing all of these things. I'm going to quickly show you how to use naive Bayes. But before we go through the code I have written, let me quickly explain how naive Bayes works and how we can use it for sentiment analysis. So this is how you see the formula related to naive Bayes. If you just try to understand, it's something like this. The first part, the left part of the formula, it's all.
I think he's muted again.
Hi Dinesh, I think there is some background sound and it's mute now.
Hello, Dinesh.
Hello.
Hello?
Yeah.
Yeah.
Can you see my screen?
Yes.
Yes.
But I think
Okay.
background.
Yeah, so let me continue. So this is the formula we basically, this is a formula related to naive Bayes, but when you go through a formula and if you try to understand the definition of it, it's very difficult to understand. So let me take an example, not this. I'm going to take you through a slide that explain how it works. So I'm using a very common example we use, and This example is actually given with one of the courses in Udemy site, so I had to give the credit to them because I'm straight away using that example for explaining this. Right. So in order to understand Bayes' theorem, we need to understand the theory related to probability. Let's take this, right? So let's say we have two machines that produce ice creams. So if you have two machines that produce ice creams, you can see one machine. So if you think about the production, so one machine is producing 60% of the entire stock or the entire production, and 40%
Hi Dinesh, we are not able to hear you.
There's a lot of background noise. Am I the only one to hear it?
Yeah, I think I'm also getting the voice, background voice.
Yeah, some squeaking noise, right?
Yeah.
can you hear me now?
Yes.
I'm hearing a lot of voices. Can you see my screen and can you hear me clearly?
Yeah.
Yes. Yes.
Yeah.
Okay, so let me continue. So I'll assume that we have two machines like this, and it's all about the production, and the first machine has 60% of the production, and the second machine produces 40% of the production. So if you have two machines like this, we can think about the probability of the production from for the machine one is 60% or 0.6, and second one is 0.4. Now, if you think about the defect rate,
Again, audio missing.
let's this defect rate of the first machine. So how do we say it? Like probability of B1 for given A1, it is 1%. And if you think about the second one, let's say the defect rate is 5%, and then we can say probability of the second, the defect rate of the machine 2 is 0.05. Okay, right. So if we know the defect rate like this, we can find the overall defect rate. So this is how you do it. You get the probability of B1 for given A1 and multiply by A1, which is the defect rate. Sorry, which is the production. Likewise, you can write the formula and get the overall
I think there is a.
I'm continuously losing my screen. I don't know why.
Yeah, I think there's an activity issue. Sometimes, yeah.
Okay, sorry for that. I'm not too sure what has happened today. I'm getting so many interruptions.
Yeah.
But anyway, I'll try to go through all of these things quickly and show you the code. So I was explaining the overall defect rate, and if I have the overall defect rate, and if I want to find out whether something has, let's say there is a problematic or ice cream, like there is an odd ice cream. So if I want to find out whether that ice cream has been produced by machine A or machine B, or machine 1 or machine 2, I can use this overall defect rate for finding it. So how do I do it? Let me take this formula. So I know that overall defect rate is formed using this formula. Okay, and this is how we have written the formula. Now, if I have an ice cream, and if I know that something wrong with that ice cream, I can check and see whether this ice cream has been produced by A1 or A2. That sort of classification. So how do you check and see? If you have the points you have one to make, all you do is just divide your overall defect rate by the same number. For example, like this, I can divide it by probability of B again, and check and see the values related to the first part of the right side and second part of the right side. So if I'm, for example, clearly for session, I know that this ice cream has been produced by first machine. If I'm getting a higher value from the second side or the right part of the right formula, it has been produced by the. So this is how it goes. If you understand, basically you have used this theory with sentiment analysis. Now, if I quickly go back to this is not Bayes theorem. This is probability. But if you go for this, that's the Bayes theorem. So probability is all about doing if you think about this from left side to right side. But Bayes theorem means you're starting from the right side and then go to the left side, because you have the machine 2. The sentiment analysis, okay, and then when I give that my new text to the machine, it can easily find out whether it is positive or negative. Okay, so it uses a theory like this. Now I know that I have spent about 4 minutes extra. I'm going to quickly show you the code I have written, and then I can go for questions.
Sure.
Okay. So I'm going to use Jupyter Notebook for getting some data and going through it. And then let's quickly apply certain libraries and algorithm to check and see how sentiment analysis work. Right. So I have I'm going to import certain packages and the libraries. You can see I'm using pandas, numpy, and NLTK. We don't have time for going through the entire code, but it's all about importing required libraries. And I'm using a text file or the CSV file that has certain records. So let me load it, and it has 12 records with 2 columns. And let me show you the 12 records. Right. So you can see I have text with the given classification. If you go through the text, you have various terms or the feedback received, based on different scenario. So you can see the text called "I love you," it is positive, and "I do not like you," it is negative. So likewise, there are certain number of texts that have been categorized into the class. So this is what we are going to give to the machine. So when you give to the machine, you have to do some transformation, but I'm not going to do much transformation with this example. If time permits, I'll go for the next example and show you how to apply, something like stemming and lemmatizing. But assume that this is the text we have along with the classification, along with the classifier. So we pass this to the machine and ask machine to find a pattern between these two. And then if you feel like machine has learned something really good, we can use it. Okay, right. So I'm in this cell, and if I execute this, basically, if you try to get the value comes from one of the columns in the pandas data frame, you can get the unique number of values you have, or not the unique, like how many values you have. So I can see I have 6 positives and 6 negatives, so it's sort of balanced data set. I'm going to make sure that stop words are removed. So this is what I'm going to do. I'm going to use stop words. As you see, I have imported stop words from NLTK, so I'm going to use that. And I'm going to tell this guy saying, okay, use English stop words, and if there are stop words, remove it. And then remember the DTM, document term matrix. In order to create DTM, you need to use this vectorizer. So I'm using vectorizer from scikit-learn. Okay, right. So it's all about converting this text, unstructured text, into a structured data set. So let me execute this, and I'll be having the vectorizer. So vectorizer is the sort of the object, the instance of the object I'm going to use. And I'm going to define my x and y. So we know that y is the class, okay, whether the values, the column that contains positive and negatives, that's y. And this one is I'm going to import count vectorizer. Let me load it, and then I'm going to use initiated vectorizer for training the machine. So how do I train the machine? I'm passing my text data from my data set. Right. So I have done the needful. If I check my records in X data set or X variable, it has 12 records and 18 columns. So how do I, we didn't have 18 columns, but what has happened is when I use vectorizer, it creates a DTM, document term matrix. So all the values coming from these texts have been converted or taken as columns. That's why we have 18 columns now. And why we have just 12 records. So what I'm going to do is I'm going to split my data set into training set and testing set. So I can simply use train test split coming from scikit-learn, and let me see it. And if I check my test data set, I have I have 3 records for test, and which mean I have 9 records for training. Okay, right. How do I do the training part? I'm going to call the fit using multinomial naive base. Okay, so I'm going to create the classifier based on this machine learning algorithm, and then I'm going to fit my data set using the X train and the Y train. Okay, so this is how it finds a formula. So once it is executed, it has some sort of formula. Remember, we are just using 12 records, which is not good. You have to use large number of records. But since this is just a demonstration, I'm not going through a large data set. Right, I have trained my machine. Let me see the accuracy. How do I find the accuracy? I have the Y test, which is this. Okay, these 3 records. I'm going to check and see my newly created classifier or newly trained classifier to whether it can actually predict these 3 accurately. So if I execute this, I will get a number. It says 75% accuracy, 75%. In a way, it is good. Now, how do I check and see whether it works well? You can see I'm creating a new array with a feedback like no way. I'm going to use the same vectorizer because I have already instantiated it. And I can check and see the feedback because I'm going to use the predict function exists with the classifier. So if I execute this, it says negative. And if I say something like I like you, it says it is positive. Even if I type something like I hate you, it says positive. But remember, this is completely based on these 12 records, which is not enough for determining something like that. But just to make fun out of it, I just added this text for doing this demonstration. So I know that it's really quick and there were so many interruptions. Sorry for that. but I tried my best to take you through all the slides and show you a quick code for implementing sentiment analysis. I have to tell you two more things. One is the data set we use, it is really small and not much relevant. So you have to pick the right data set with large number of records. Second thing is you have to make sure you apply transformations. Okay, so I don't think I have time for showing the second code, but basically you can apply other type of transformation which we not demonstrated, but we discussed something like lemmatizing, regular expressions, things like that. Okay, so I can spend 1 or 2 minutes if you have any question, or we can take question offline.
Hi everyone, you have any questions to ask now? Sorry for interruption. Yeah.
No questions, right?
I think no.
Okay. I know that it in a way it is too much. Like I was trying to cover so many things within 45 minutes.
Yeah.
But if anyone has question, you can reach me via emails or WhatsApp or Facebook, anything. And if you have any question related to the code I showed, the slides I discussed, please let me know. And once again, extremely sorry for the interruptions. There are some electricity issues today, so we don't have electricity now for some reason, and I'm using a different mobile connection for connecting with the internet. That's why I'm getting so many interruption, and I have no way using my the regular microphone. So you might get some noises from my background as well. Okay. If no question, thank you very much. So over to you, Asif.
Thanks.